and welcome to today's video on derivatives of logarithmic and inverse functions. So, I suppose a good starting point is asking, what is an inverse function? Well, it is the function f of x reflected over the line y is equal to x, but it has a very interesting property. F of f inverse of x, no matter what x you put in, is always equal to x. So, what this is really saying is f inverse is the function, or let's say that we have f of x outputs a y. F inverse of y is equal to x. So, we are going to use this property to show how can we find these derivatives of inverse functions even if the inverse does not exist. So what we start out by doing is we're going to take the derivative with respect to x of both sides of our original function, f of f inverse of x, and this is something that we're going to be doing a lot in this video and the next video. So we're going to get, using the chain rule, the derivative of f with respect to f inverse of x, f inverse, times by the derivative of f inverse with respect to x. That's just the chain rule. And the derivative of x is just 1. Well, what's the derivative of f with respect to f inverse? That's just f prime of f inverse of x times by the derivative of f inverse of, with respect to x, is equal to 1. Now, if we want to solve for this f inverse of x over dx, then we can just divide this f prime of f inverse of x over. So we get d of f inverse over dx is equal to 1 over f prime of f inverse of x. So this is just something general that we're going to be doing a lot today, and this is how we are going to prove the derivatives of the trig and the logarithms. So in order to prove or to show what the derivative of a logarithm is, we need to have something that we know. What do we know? Well, we know that f of f inverse of x is equal to x. Okay. Well, what does this give us? Well, we know that the logarithm is the inverse function of an exponential. So let's say that we have b to the power of logarithm base b of x, and that's equal to x. Now we can take the derivative of both sides with respect to x, and we know what this derivative is. We've done it before. The derivative of an exponential is the base of the exponential, so the natural logarithm of b, times by the exponential itself, and that is times by the derivative of this inside, which we don't know yet. So we're just going to call it d over dx base b of x, and that's equal to 1. Now what do we do? Well, we can now we can divide by the natural log of b times by the exponential b to the power of log base b of x. So what we get is d over dx of log base b of x is equal to 1 over the natural logarithm of b times by b log base b of x. Well, we know our properties of exponentials and logarithms because their inverses. This here is just x. So we are left with the derivative of a logarithm base b is equal to 1 over the natural logarithm of b times by x. Or sorry, times by x. Let's do this one more time just for some more practice, this time with natural logarithm. Well, we know the natural logarithm, and I'm going to state this, b is a constant. That's important you state that. I forgot to state that in the beginning, and I'm sorry for my weird tangent. But anyway, now let's do the natural logarithm. So we know the natural log, so e to the natural log of x is just equal to x. We now can take the derivative with respect to x of both sides. We get e to the natural log of x times by the natural log of e, but that's just 1, times by the derivative of the natural log of x, and that is equal to 1. Now we are going to divide this e to the natural log of x to the other side. So what we get is 1 over e to the natural logarithm of x. Well, if that's the case, then e to the natural logarithm of x, that's just 1 over x. And isn't that something really cool? This transcendental function here has a derivative that is a purely algebraic function. But now that we have these tools and we know the derivatives for these functions, we can now do some practice problems. To start out, let's find the derivative with respect to x of the natural log of natural logarithm of x. So this is a chain rule. So we know that we take the derivative of the outside function, which is going to be 1 over the natural log of x, times by the derivative of the inside function, which is 1 over x. So we get 1 over x natural log of x. Okay, now what do we do for the second one? Well, we can use some properties of logarithms, which I find, because if we don't, this is a 3-link chain where we'd have natural log of x, x squared, and then sine of x. Which that's a lot to do, so we're going to not do that. So we are going to say that this is really the same thing as taking the derivative of 2 natural log sine x. Because logarithm can bring powers outside of it. Even if it's like a trig function raised to a power. So what we're left with is we get the derivative. Well, we always take the derivative of the outside first, which is going to be 1 over sine of x times by the derivative of sine of x, which is cosine of x, times by 2. Well, sine times by cosine, and we don't need that derivative anymore, that is just 2 cotangents of x. And now that's a function that looks completely different from our original. Finally, for this last one, we are going to say that this is d over dx. Well, we're taking the natural logarithm to the -1 power, so this is a power and then a logarithm. So we bring the negative out front, natural log of x, times by, to the -2, times by the derivative of the natural log of x, which is 1 over x. So we are left with negative natural log of the natural logarithms to the -2, which in all honesty, we're just going to put in the denominator. So we get 1 over x natural log squared of x. Interestingly enough, this looks oddly similar to this function over here. So for this next topic is going to be logarithmic differentiation. So you may ask, how do we take a derivative of a function that is in the form y is equal to f of x to g of x? And there's no real rule for this. We can't particularly do this. However, what we can do is a product rule. So how do we make this into a product? Well, let's use some very nice properties of logarithms, and we're going to take the natural logarithm of both sides. So we get natural log of y is equal to the natural log of f of x times by g of x. Or rather, let me show all of my steps here. Now we can use the properties of logarithms, more specifically the natural log of a to b is equal to b natural log a. So what we get is the natural log of y is equal to g of x times by the natural log of f of x. Okay, now what do we do? Now you can take the derivative. So whenever we take the derivative of this left side, we are going to get, well, the derivative of the outside is going to be 1 over y. However, this is an implicit function, so we have to take also the derivative of y with respect to x. And that's going to be equal to the derivative of the first, which is just going to be g prime of x, times by the derivative of, or sorry, not the derivative, but the second function, which is natural log of f of x, plus g of x, times by the derivative of the second function. In this case, you have to take the derivative of the outside first, which is going to be 1 over f of x, times by f prime, the derivative of the inside, which is f prime of x. And then now all you have to do is multiply the y over, so you'll get dy dx is equal to all of this jumble over here, times by the natural log of f of x plus g of x times by f prime of x all over f of x times by y. And the final step that you do is always sub in the y for the original function. So you'll get f of x to the power of g of x. So that's going to be the basics of what you're doing. So now I'll work through 2 actual problems with you and not just going through the steps. So once again, first things first, for this first one, we want to simplify this. So this is going to be d over dx of x to the power of 3 sine of x. Alright. Well, we need to set this equal to something, so we'll say that this is equal to y. Okay. So now we are going to take the natural log of both sides. So we get the natural log of y is equal to the natural log of x cubed, or sine of x. Alright, now we use our properties of logarithms to bring this down, so we get the natural log of y is equal to 3 sine x natural log of x. Now I just have to take the derivative with respect to x of both sides. So we get the derivative with respect to y of the natural logarithm, that's just 1 over y. The derivative of y with respect to x, that's y prime. And that's equal to the derivative of the first, well, that's going to be 3 cosine x, times by the second, that's just natural log of x. Alright, plus, well, we have the 3 sine of x times by 1 over x. Alright, now what do we do? All we have to do is multiply this y over, so we get y prime is equal to 3 cosine x natural log of x plus 3 sine x times by 1 over x times by y, We substitute in our y for our original function, which is going to be x cubed sine of x. And that is our answer. Now we got another problem here that we need to work through. So we have the derivative of tangent to the natural log of x. So this is going to be very logarithmic-y. So let's see what we're going to do. We're going to start by setting this equal to y. So y is equal to tangent to the natural log of x. We're going to take the natural log of both sides. We're going to use logarithmic properties to make this the natural log of x times by the natural log of tangent of x, okay, is equal to the natural log of y. Now we take the derivative with respect to x of both sides. So we are left with the derivative of the natural log with respect to y. That is just 1 over y times by the derivative of y with respect to x, which is y prime, is equal to the derivative of the first, which is x, and I'm just going to put all of this, rest of this over it, ln of tangent of x, all right, plus natural log of x. The derivative of the natural logarithm is going to be the derivative of the logarithm, 1 over x, so that's going to be a tangent of x, times by the derivative of tangent. The derivative of tangent is secant squared, so we get times by secant squared. And then finally, we multiply the y over, so what we get is times that by y. We know that y is equal to y is equal to tangent natural logarithm of x. And that's all you have to do. And that's all I have for you today. In the next video, we're going to be going over inverse trig functions, which are, in all honesty, some of the funnest, in my opinion, to prove.